Hey guys, so welcome to this video. This video is will be an extra practice problem on torque, and let's go ahead and start by reading this problem. We have a lug wrench that's being used by two people. Person A applies a 50.0 Newton upward force, and the force is 0.35 meters to the right of the axis of rotation. And person B applies a force of 22.0 newtons downwards, and that force is 0.50 meters left of the axis of rotation. Okay, so this is, oh, and the last part is, what is the net torque if both forces are perpendicular? So this picture here I have in front of me is it's a crude drawing of a lug wrench. And so let's go ahead and label the things that are given to us. All right, let's start with person A. Person A has a upward force here of 0.35 meters, and it is not entirely drawn to scale, but I'll do the best I can. Upward force, and let's label that force exerted by person A, 50.0 newtons. And how far is this force from the axis of rotation? Well, it is 0.35 meters. Okay, and this is this you can call this from the radius of person A. The other force is by person B, and they are applying a force downward, and they are located left of the axis of rotation. So it's something like that. And the force by person B is going to be 22 newtons. 22.0 newtons. Okay, sorry, that kind of crossed over a little bit. 22.0 newtons. Actually, let's actually erase that for just a moment. A couple things here. Extra detail. Maybe I should give myself more room. Force of B is not just going to be 22.0 newtons. Okay, if I want to emphasize it's going downward, I'm going to apply a negative sign right there. Okay. Likewise, the forces to the left of the axis of rotation. So direction of left, RB. Right, if I want to apply it to the left, it's not only just 0.50 meters, it's going to be negative 0.50 meters. And yeah, so this is the information we have, both forces and both radiuses. What is torque defined by? Oops. Torque is defined by, first of all, it's represented by this symbol right here, tau. That's going to be our representation for torque. It is defined by the force times the radius. Sometimes it's interchangeably called distance as well, times sine of the angle. The angle in this problem are perpendicular, so it's going to be 90 degrees. Okay? And sine of 90 degrees. Okay, and basically we just have to do this twice. Okay, so we have the torque of person A. Let's start there. Torque of person A is going to be 50.0 newtons. And the distance, or the radius of that from the axis of rotation, is going to be 0.35 meters. Right, and just for this first time at least, it'll be sine of 90. Okay. And torque A is just going to be 18 Newton meter. Okay, that's the torque exerted by person A. if I move on to B, torque exerted by person B here, and I'll write it up here. Torque exerted by person B. Again, the force, in this case, the force exerted by person B is going to be negative 22.0 newtons times the radius, which is going to be also negative because it's to the left, negative 0.50 meters. Alright, and I'm running out over here, sorry guys. And sine of 90 will be 1 still. And when we take a moment and calculate the torque exerted by B, both negatives cancel out. And we will have a torque of 11 Newton meter. Okay, so we have the individual torques by a person exerted by A, and then torque by person B. Right. So the last step for us here is just this. We have to find the total torque, in this case, and I am kind of all over the place here, the net torque is basically just taking torque exerted by person A plus torque exerted by person B. And it's going to be as simple as 18 Newton meter plus 11 Newton meter. Okay, and the net torque is going to be 29 Newton meter. Okay, and that is it for this problem. Okay, I hope that clarifies any questions, and I hope you find this helpful. Thanks for watching this video, and I hope this is helpful for the quiz or possibly test coming up. Thanks for watching.